Okay, welcome back students. So in the previous class, what we have done, we completed the chapter 7, data file handling. So in this class, we will start the new chapter. Then chapter is what? Pointer. Okay, chapter 8, and 8 is what? Pointer. So what is pointer? We already study some definition, basic thing about pointer in HS first year. Okay, so I again remembered you. So pointer is what? Actually, if anyone you asked you that what is pointer, then you have to say pointer is a variable, okay, which stores the memory address of other variable. Actually, pointer definition is a pointer is a variable which store the memory address of other variable, or you can say memory location of other variable, same thing. Means pointer is what? A pointer is a variable which store the memory address of other variable. Means, you know, in computer, every data, every instruction, means you can say everything has a unique memory address, right? Everything has a unique memory address, and that memory address stored by a variable, and that variable is we call as pointer, right? Means suppose int a is equal 20, that a is integer variable, and this 20 is the key value of the variable, and these have a unique address memory, suppose 1001, and that 1001 stores in a pointer, okay, and that is called pointer. So we discussed briefly about this thing in this chapter. So this is the first basic definition. First of all, we need to study one concept, okay, memory concept. In computer, memory actually one thing, memory map. One concept is we have to call memory map. Memory map, right? So we have to be first of all understood this thing. What is memory map? Memory map is divided in 4 parts, right? First part is called program code, okay. Second part is called global variable. Third part is called stack. The last one is heap, okay. We need to study from the root of this topic. Then you easily understood what is pointer. Otherwise, you never be understood the pointer concept, because it is easy concept, but it is somehow perplexed, somehow it is confusing. Many students confused about pointer, how it is work, how it is accessing the value, okay. So that's why we have to study from the basic part, okay. In memory map, I can say you there is 4 section, okay. First person is what? Program code. Second portion is global variable. Third portion is stack, and fourth portion is heap storage or heap memory. Somehow it is called heap storage, and sometimes it is called heap memory, HEAP, right? So what is program code? In program code, when we compile a program, then the program instruction is stored in program code section. Okay, when we compiled a program, the compile code is stored in program code section, right? And in the global variable section, what we have stored? We stored the global variable. And what is a global variable? I already told you the difference between global variable and local variable. Global variable is what? Which is defined outside the main function. And what is local variable? Which is defined inside the main function, right? In the global variable region, we have to store the global variable, right? And in this stack, what we have to store? In stack, we have to store what? The return address. Some memory address will be returned. And in stack, we have to be store some return address and local variable. We have to be store some return address and what? Local variable, right? In program code, we have to be stored some compile code, means when we compile a program, means when we compile a instruction of the program, then that portion will be stored in what? Program code. And global variable, what we have stored? We stored some global variable. And in stack, we store some return address of return address means return memory address. Okay, return address means return memory address and local variable. And this is the important. What is heap? Heap means free storage memory, which is allocated dynamically. Okay, means memory allocation is done by two ways. Okay, memory allocation means what? Allocation means consumes. Memory is consumed by two ways. One is static and other one is dynamic. We have to study briefly in the next section. One is static memory allocation, and second one is dynamic memory allocation, right? And in heap store memory means the free storage memory, in where memory is allocated, by which? Dynamically, right? Okay, so now we have to study detail in what is static memory allocation and dynamic memory allocation. This is the concept memory map. Okay, all thing we have to be understood, first of all understood clearly. After all, we have to be clearly understood the pointer concept. Okay, if I first of all I just teach you what is pointer, then you will be somehow confused then how it is work. That's why I started from the very basic thing. Okay, that's for your easy understanding of this topic pointer. Okay, and this is important. There are two ways of allocating memory, right? One is static memory allocation and second one is dynamic memory allocation, right? So what is static memory allocation? Means when you heard the word static, means what will coming in your mind? Static means what? Constant, okay? And dynamic means it will not constant, it will be dynamicity character, means it will be variety, okay? It has variety. And static means it has what? It has constant and fixed, right? So when we study static memory allocation, means in here memory is allocated, okay? Again I tell you that you have to make the note by yourself, okay? I can't provide you the note. I can tell you, you can make this, okay? You have to make the note of on behalf of this topic by yourself, and you can easily get in the book, okay? In the textbook, right? So I just give you the concept. So in static memory allocation, memory is allocated in compilation time. Memory is allocated in compilation time, and in dynamic memory allocation, memory is allocated in runtime. So this is the basic difference. What is basic difference? Static memory allocation, memory is allocated means memory is consumed in compilation time, right? At the time of compile. When we suppose we write a program, and after writing the program, first of all we have to done? We have to done compiling. Means if any error is exist or not, so we have to first of all compile the program. And when we compile the program, some memory is allocated that instruction, right? Okay, when we compile the program, the instruction, the memory instruction, sorry, the program instruction is what? Consume some memory, because I already told you that everything in this in a computer is under a memory location, means under a specific individual what? Unique memory address, right? So when suppose we write a program, and when we compiling that program, when compiling the instruction of the program, at the time of the compile time, when it compiling, at that moment the instruction is consuming some memory, means allocated some memory, and that concept is called static memory allocation, right? And after the compiling, when suppose no error is existed, suppose your program, your coding is completely correct, at the compilation time there is no error, then your instruction will be what? Go to the run, okay? Run processing, means it will be finally executed per processing stage, right? So at the time of execution, means at the time of run time, where the instruction consume the memory, okay? When the memory allocated, and then at the time of run time, means at the time of execution, and that memory is called, means at the time of runtime memory, that memory is called dynamic memory allocation. Means it is actually used in heap storage. Heap storage means at the free storage time. I again tell you, I already teach you the memory map. At the last section of the memory is what? Heap. Heap storage means at a free storage, which is allocated by dynamic memory allocation, right? So it is a basic difference. So in dynamic memory allocation, there is two operator. Okay, there is two operator. In dynamic memory allocation, there is two operator. One is new, and another one is delete. Okay, and what is the purpose of this new operator and dynamic delete operator? New operator means it is allocation of the memory, and delete means it is deallocation of memory. It is allocation memory, and it is deallocation of memory, right? So at that when we use new, okay, means the operator new allocates the memory dynamically and returns a pointer storing the memory address of the allocated memory. Means you see, allocation of memory means suppose there is a program, suppose program in integer 2, okay, int 2. int 2, suppose we have to take a variable a is 2, and this is suppose memory address 2002, and 2002 is memory address is return to where? Return to the pointer variable. And means in this process the allocation of memory, this is done by a operator new. And suppose we have to delete the variable, means, and this variable is coming in the new variable, and this new variable memory address is 200.4, right? And this is done by delete operator. Sorry, this is not by delete operator, this is done by delete operator. This is done by delete operator. Means we have to deallocate this variable and we have to here put, means again it is by new operator purpose. It is operation is again by what? New operator, right? Means what we have understood? We have understood that we have to perform this dynamic memory allocation by two basic operators. One is new, second one is what? Delete. And delete is for allocation of memory and returning the address, memory address. And returning the memory address is going to where? Going to the pointer variable, right? And delete operator is by deallocation of memory, right? Okay. So next is we have to study a topic. One is that is free store. Free store. Okay. Free store. Okay. Free store is somehow similar to where? Heap storage. Okay. I just write down. Free store is a unallocated heap memory given to a program. Free store is unallocated heap memory. Unallocated means what? A heap memory is what? Heap memory is a free memory where we can allocate this memory by dynamically, means by new or delete operator. Okay. And free store is unallocated heap memory, means it is free heap storage, means it is somehow similar to heap memory. Okay. And which is, so unallocated means what? It will be blank, it will be free, okay, and it is allocated through dynamically, right? Allocated through dynamically, okay. So free store, if you have to write the definition, means what? Free store is a pool, okay. Free store is a pool of unallocated heap memory. I write down the definition. Free store is a pool of unallocated heap memory. Unallocated heap memory. Unallocated heap memory. Okay. Given to a program. Given to a program that is used by the program by the program for dynamic allocation during execution, right? Okay, what is, I already tell you, this is a free storage, a pool of unallocated heap memory means free storage given to a program that is used by the program for dynamic allocations. Means we have to use two operators, new and delayed, during execution means during the runtime. And what is dynamic memory allocation? It will be allocated the memory during the runtime. Okay, static means during the compilation time, right? So next one is declaration of an initialization of pointer. Declaration and initialization of pointer. So pointer is declared by how you can declare a pointer. Pointer is declared by a symbol, and that is you can call this unary operator. This is called unary operator, or this is sometimes called asterisk. Okay, this symbol is called asterisk, and sometimes it is called unary operator, right? So but we have to define a pointer by this symbol. Okay, see now pointer is how many types? Means pointer is what? Pointer is actually type. This type means what? Type means valid C++ data type. Okay, type means valid C++ data type, and here underscore name is variable name, right? Type is valid C++ data type, and here underscore name is variable name. Okay, suppose this is character, okay, ch, was character cptr, we use cptr, and float fptr. Means what is the first pointer we declared? The first pointer is what? Character pointer. Means we have to store the memory address of which variable? What type of variable? Character type of variable. Okay, this pointer is what? Character pointer. And character pointer is store what? Character pointer is store only the character variables. Suppose character A. Okay, means A is what? A is store data type character, and it has a memory address suppose 1001, right? And this is stored by this character pointer. Okay, suppose int 2, then this memory address is stored by int pointer, and suppose that type of float means pointer 2.50 something, and that will be that's memory address, means that's memory address is stored by what? Float pointer. Now the concept is what? I hope you remember one thing, the memory value, memory address. I already give it a chart in first year. So what is the memory allocated by character, integer and float, and that data type? Integer consume 2 bytes memory. I hope you remember. And character consume 1 bytes. And float consumes 4 bytes. If you see, and there is other also type, integer type, assign integer, unsigned integer, short integer, long integer. Character is sometimes sign, unsigned. Float is also float, and next is more precision will be required. If we will be held, then will be exist, then we have to take data type double, okay, a long double, short, okay, short double, okay, something like use. But generally just you remember the int integer type of any value variable allocate how many memory bytes? 2 bytes, and character 1 byte and float 4 byte, right? So if suppose you declare int a and int iptr, means integer pointer, and one is character b, then you cannot hold this. You can hold this pointer memory location only, because a is integer. You cannot hold this memory location of this. Why? I tell you why. Because in character, when we declare int pointer, means we have declared 2 byte memory location. 2 byte memory location. Okay? We declare 2 byte memory location. Then if we store this character variable, then 1 byte is what? 1 byte is free storage. Means this will be what? This will be unnecessary some memory location in the integer pointer. You got it? I can tell you. See, suppose I again concept you the float b, okay, and the float data type. How many memory locations we have to require? 4 bytes. And integer pointer, integer means what? We have only 2 bytes. B is equal, suppose B is equal 2.50, okay, A is equal 2. For two variable, there is, we have to take 2 bytes memory location. 2 bytes memory location, okay, 2 bytes memory location. Because, so okay, A is equal, suppose we take 6. Means 2 bytes memory location, because 6 is what? Integer. And for integer data type, we have to take memory location, memory for consuming memory 2 bytes, right? For it is stored by what? int pointer, iptr. For float data type, we have required 4 bytes memory location, right? We have required 4 bytes memory location. Right, for 4 bytes, how it will be stored in integer pointer? Means it will finally what is happen? It will loss of information. Loss of information. And why loss of information? Because in float data type we have to be 4 bytes memory location. But we take only int pointer, integer pointer. How we can store this variable memory address? How we can store this variable memory address? How? Because we need to be 4 byte memory location, but we have only 2 byte memory location because it is int pointer. Then this finally what happened? The loss of information, right? Okay. So this will be enough for this class, okay? In the next class, we have discussed further on this topic. So, thank you.